Today's video will explain the various indices associated with the Deque. Hello, I'm James Helfrich. Two of the most common implementations of the Deque are the wrapping array and the array of arrays implementation, and each of these use indices in a non-trivial way. This video will explain the various indices and how to compute them. So there are two main implementation options for the Deque, one of which is the wrapping array. The wrapping array implementation consists of a single array of elements in which values can be pushed onto or popped back from either side. For an example, I have a Deque, which I'll call D, and I'm going to push back 7, push back 8, and push front 6. So I'm going to start with an empty Deque, and I'm going to initialize this with 4 elements in it. I'm going to push back 7, push back 8, and then push front 6. Now notice, since it's a wrapping array, it's going to go around to the back slot. Now, the array of array implementation consists of an array of pointers, each pointer referring to an array of values. So once again, I have the same values here, and I'm going to initialize my Deque, which is going to have no elements in it. I'm going to push back 7. Now 7, I'm going to need to have a block. I don't have a block yet, so I'm going to allocate a block. My block is going to have 4 elements in. I'm going to push back 7 onto that. Then I'm going to push back 8 after that. They're going to push front 6. Now, in order for me to push front 6, I need to allocate a new block. Well, I already only have room for 1 block currently, so now I got to reallocate. So now I have room for 2 blocks. And now I'm going to push 6 in front, which goes in the last spot. All right, let's take a look at these in more detail. The wrapping array indexing has 2 index schemes, ID and IA. ID is the Deque index, and this is what the client sees. In other words, when they go look for slot 0, slot 1, slot 2, they're going to be passing a Deque index. We also have an array index, and this is how it's stored in memory. And initially, the first slot is an IA equals 0, but we may change this according to how we're wrapping. And I can find my array index from the Deque index by taking my Deque index, add IA front, the index of the front element, and mod by the num capacity. So let's see how that works here. First of all, I'm going to have 5 different elements in my Deque, A, B, C, D, and E. So I'm going to have A, B, C, D, and E. Now notice how my Deque and array indices are both the same, and they're both the same when IA front equals 0. There's no offset. So now I'm going to pop back. When I pop back, I'm going to remove 1 Deque element. So my array index is still 0 through 4, even though slot 4, my array is not used, but my Deque indices are 0 through 3 because there is no slot 4. Now, when I pop front, now I'm going to remove A from that. Now my Deque index is going to be array index 1. In other words, there's an offset. Things are scooted over by 1, and we know that because IA front now equals 1. And if I pop front again, now I'm going to get rid of B, and now C is Deque index 0, and D is a Deque index 1. But notice how array indices remain unchanged. In other words, we're not moving the elements around, they're staying in their location. But since IA front equals 2, then I can take my Deque index of 0, add 2 to it, and that'll show me where it is in my array index. And that's how I actually find the value in memory. Okay, so let's take a look at this example here. I have a Deque where it has a collection of capital letters in. I'm going to push back, push back, push back, push front, and pop back. Now my IA front equals 6. And here is how my Deque looks in memory. Now take a minute here, pause the video, and see if you can fill in the values for IA and ID for the values C, D, E, F, G, and H. So let's take a look at E. E is going to be array index 0, and that's because it's at the front. So therefore, array index is 0. But my Deque index, well, it's C is Deque index 0, D, E, this is going to be Deque index 2. Now, F is 1 after it in memory, so therefore my array index will be 1, and then my Deque index will be 3. Then G is array index 2, 0, 1, 2, and my Deque index will be 4, and then 3 and 5. Now, let's take a look at C here. What's my array index? 0, 1, 2, 3, 4, 5. It's going to be in slot 6, but from a Deque standpoint, it's the first element, or index 0, in my array. So let's take a look at that same thing again. I'm going to drop my array indices in. I'm going to drop my Deque indices in, and we can see how IA front is going to shift everything over by a few values. When we have an array of arrays, things are quite a bit more complicated. We actually have 4 index schemes. We have ID, just like before, which is my Deque index, and this is how the client sees things. Then I have my cell index, and that's the index within a given block, 0, 1, 2, 0, 1, 2, 0, 1, 2. And then I have my block index, and how many blocks am I going to have? However many different blocks there are. In this case, I have 5 blocks, block index 0, 1, 2, 3, and 4. And then finally, I have my array indices. My array indices are what would happen if I put the blocks back to back next to each other in memory. And you can see the array index are 0, 1, 2, 3, 4, 5, 6, and then A is in slot 7. Now here, I can always compute my array index for my Deque index by taking my Deque index and add IA head or IA front, and then mod it by the number of elements I could have before I reallocate, which is number of cells times number of blocks. Now, this is very similar to my wrapping array computation. The difference is I'm not done yet. I need to find my block index and my cell index. And my block index is going to be IA divided by num cells using integer division. And my cell index is IA mod num cells using modulus. So I could take this exact illustration and lay out my blocks side by side, and you can see how their blocks and arrays are next to each other. My block index 0 and 1 are not utilized right now. 2, 3, and 4 are. We can see my array indexes go 0, 1, 2 for uninitialized block 0, 3, 4, 5 for uninitialized block 1, 6, 7, 8 for block 2, 9, 10, 11 for block 3, 11, 12, 13, 14 for block 4. But we also have our Deque indices, and this is what the client sees. And the client sees that A is in slot 0 and B is in slot 1 all the way up to F in slot 5 by my Deque index. So once again, I have my Deque, my cell, my block, and my array indice. So let's walk through a little example here. The same thing we did before with wrapping arrays. I'm going to fill up my Deque with A, B, C, D, and E. Okay, so I have A, B, C, D, and E. Notice my block is of size 2. Now, just to make sure we understand how this works, we're going to drop in my block index, 0, 1, 2. Notice how block 3 is not allocated. I'm also going to drop in my cell indices, 0, 1, 0, 1, and 0, 1. Now, currently, IA front is at slot 0. In other words, my array index and my Deque index are aligned because there's not offsetted at any point in time right now. And this is usually the case when we just push back. Now let's take a look at my Deque indices. My Deque is 0, 1, 2, 3, and 4, and those are the slots that are finished, and I'm going to represent that with that orange color. And my array indices 0, 1, 2, 3, 4, and 5. And if I had block 3 allocated, it'd be 6 and 7 as well. So now I'm going to pop back, and it's going to remove E. Now, when I remove E, that entire block is now empty, so I'm going to unallocate it, and it's going to disappear. So now my array indices 0, 1, 2, and 3 are going to be allocated. 4, 5, and 6, 7 are not because they corresponding blocks that are not allocated. And my Deque indices remain 0, 1, 2, and 3. Now, when I say pop front, what's going to happen now? The first thing I'm going to do is I'm going to remove A, and that's going to shift my Deque indices by 1. So my Deque index goes blank, 0, 1, 2. My array indices stay the same. In other words, my array indices are independent of whether there's elements in it. So now I'm offset by 1, so my IA front equals 1. And if I do one more pop front, now I'm going to remove that entire block. And now just notice how IA 0 and 1 correspond to unallocated blocks. 2 and 3 do have a block. 4, 5, and 6 and 7 do not. My IDEC is going to be 0 for C and 1 for D. And so now my offset is going to be 2. This is the same example we had before, the wrapping arrays. Pause the video and see if you can fill in this table for the corresponding array, block, cell, and Deque indices for the values C, D, E, F, G, and H. Okay, let's begin with E. Now, E is slot 0 with my array, and it's also in block 0, and it's in cell 0. We expect that to be the case because if I take IA and divide it by number of blocks or mod it by number of blocks, I'm still going to get 0 for each one of those. But what's my Deque index for that? Well, since C is the beginning, 0, 1, 2, I expect my E to be in slot 2, and it is. Now, F is going to be 1 greater for IA, but it's going to be in the same block. In fact, both E, F, and G are in block 0. E is in cell 0, F is in cell 1, and G is in cell 2. And after E is F, so from the client's perspective, F is slot 3 from a Deque index, and G is in slot 4. And of course, IA is going to be 2 there. Now, what is H? H is going to be 1 greater than the array index because it's next in line, so that's 3. Which block am I? No longer block 0. I'm now in block 1. And my cell is block 0. And this is going to be, what is my deck index? C is 0, 1, 2, 3, 4. 5 is for H, so it's going to be 5. Now, what is C? Well, from an array's perspective, C is going to be 0, 1, 2, 3, 4, 5 for the first 2 blocks. Notice the next block is empty, 6, 7, 8, 9, and 10. So my array index for C is 10. My block is going to be 3, and my cell is going to be 0. But notice this is the beginning of my deck, so my deck index is going to be 0. It's the head of my deck. D is 1 after C, so it's 11. It's still in block 3. Notice no one's in block 2 because block 2 is empty. My cell index is going to be 2 because it's the end of the block, and my deck index is going to be 1. Let's verify how this looks here. I'm going to take the same exact structure. I'm just going to lay the blocks out side by side, and I'm going to drop in my array indices. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. Notice 6, 7, 8 are in blocks that are not allocated. And I'm going to drop in my block indices, 0, 1, 2, and 3. Notice how block 2 is not allocated. And finally, I'm going to drop in my deck indices, where C is in slot 0, D is in slot 1, 2, 3, 4, and 5. And then sure enough, IA front is in array index 10. You can learn more about this in the deck chapter of the C++ data structures textbook.